Hey class, so welcome to the Unit 3 review part 2. We're going to be exploring another problem set that will help us get ready for our exam that's coming up. Let's go ahead and get started. So this first problem says a group of 33 people attended a ball game. There were twice as many children as adults. Okay, so I'm going to go ahead and pause there because I feel like that's important, alright? Can we get information like that? So twice as many children as adults in the group. And let's go ahead and go back, and they said 33 people. Set up a system of equations that represents the number of adults and children who attended the game, and solve the system to find the number of adults and children who are in the group. Okay, so this one's a little different than other ones that we've seen. Usually they give us like money or like books and CDs. We've done problems like that. This one is talking about adults and children, and what's interesting is they tell us that twice as many children as adults. So if I say that C equals child and A equals adult, okay, how would I represent this as twice as many children as adults? Well, if I have one adult, then I would have two children, right? If I have two adults, then I would have four children. Three adults would be six children. So really what I'm doing is I'm doing 2 times the adults equals the children. Okay, we'll say that again. 2 times the adults equals the children. Okay. And they're saying that adults plus children equals 33. And so we can use this information to solve for our group sets. Well, A says A plus C equals 33. That's true. And then it says children is the adults plus 2. No, that's not how we're going to get twice. This is no good. Okay, B says A plus C equals 33. That's good. And then adults equals children plus 2. No, we just said that couldn't be good, right? We have to multiply. C says A plus C equals 33. Okay. And that children equals 2 times the adults. Okay. That seems right. Let's check the last one. A plus C equals 33. That's good. And that adults equals 2 times the children. Well, we don't have twice the number of adults. We have twice the number of children. So this is no good. And you can look at the values too. Which one should we have more of, children or adults? Well, we should have more children. 22 to 11 is twice, right? So our answer here has to be C. The main skill that we want to focus, guys, is making sure that we're able to set up these equations. Okay? Let's go ahead and go on to the next question. So what is the solution of this system? Okay, so when solving this, guys, you all can actually use Desmos to solve this. Graph the two equations and see what solution you get. I'm going to go ahead and do this by hand, though. You guys can follow along. At 3x minus y equals 3, and negative 6x plus 2y equals 5. Well, I'm going to solve this using elimination. I'm going to multiply this equation by 2. So when I distribute everything, I'm going to get 6x minus 2y equals 6. Okay. 6x minus 6x, well, that's 0. 2y minus 2y, well, that's also 0, equals 6. Well, 0 equals 6. Is that a true statement? That is not a true statement. That's not true. 0 does not equal 6. And when we have this type of situation, that means that there are no solutions. Okay, I want you guys to graph these two. And you're going to observe that these two lines are parallel. In other words, they don't touch. Don't touch. So there's no solution. Okay. Let's go ahead and move on. Solve the system of inequalities by graphing. So for this one, definitely use Desmos because your test will be timed, right? And so I want you practicing that skills, but I'm going to go ahead and do this by hand. I'm going to look at this first equation. You know that my slope is -1, my b is -3. So I'll come down to -3, and then -1. So it looks for sure that this line satisfies that first equation. And this is y is greater than or equal to, so we need to definitely shade above. So this is true. Okay. If I look over here, okay, this line for C would follow the same thing. Okay. Follows the same line. This is also true. Good to know. This on B, nope, this is a no-go. And on D, well, the line is good, but the shading below, so this is a no-go. So we got to check the other equation. I'm going to change it to red. Let's do -1. So come down to -1, and then 1/2. Okay, so this line is good, and we need to shade below. Okay, so it looks like it's going to be A. Over here, follow the same line. Oh, we have the same line, but we should be shading below, so it's got to be A. Double check my answer, double check your answers using Desmos. Okay, same situation. Okay, this time we've got slightly different scenario. We've got m equals 3/2, and our y-intercept is 1. So when I come to 1, let's check these lines. Okay, I'm going to come up to 1. So we're here, and then 3/2. So I would need to rise 3, 1, 2, 3/2. So this is where our line should be, but it's not there. That's no good. For B, come up to 1. Cool. 3/2. 1, 2, 3, 1, 2. Okay, well, this line looks good. As far as shading is concerned, we should be shading everything below, right? Because y is less than. So let me shade everything this way. Okay. The next line says y is less than or equal to -2. So there's no slope on this. It just has this y intercept axis at -2, which creates this straight line, and we would shade everything below. There you go. Double check this into Desmos, and we're going to go ahead and just move on from there. Okay, we're in the same type of question set here, guys. Well, this one we do have to do a little bit of work. We say m is 1/3, b is 2. So I go to b is 2. And then 1/3 would be up 1/3, 1, 2, 3. So our line would be here. Well, this is obviously not good. For B, our first intercept is at 2. This already looks like it's not going to work again. We go up 1/3, 1, up 1/3, 1, 2, 3. Nope. This 2 is not going to work. Okay, for C, we go up to 2. 1/3, so we go up 1, 1, 2, 3. This looks like it could work, but we need to shade everything below, so not too sure about this. Let's check the next one. At 2, go up 1/3, 1, 2, 3, shade below. Okay, this looks good. This looks good. Let's check the second equation here on D. It says that our slope is -1, our y-intercept is -2. So if I go down to -2, and if my slope is -1, I go down 1/1. Okay, so this line is good. How do I shade? It says y is greater than, so you shade above. This is our double shaded region, so it's obviously D. Go ahead and plug these equations into Desmos, and double check our answers. Okay. This one here says, consider the following inequalities. We've got 4x plus 3y is less than or equal to 800, and 20 is less than x plus y. Okay. It says, if x represents the number of hamburgers sold at a restaurant, and y represents the number of french fries sold. Okay, so x is burgers, y is fries. It's important. I'm going to go ahead and highlight that. Okay, y represents the number of fries. Okay, that's important. Which of the following statements can be considered true? Okay, so the restaurant makes $4 profit from each hamburger. Okay, so let's go ahead and color code this. Let's say $4 profit from each hamburger. So that's that 4 there. Okay, and $3 profit from each fry. Well, that's this right here. The restaurant will never make more than $800. So yeah, this seems pretty true, right? So it's 4x, which is $4 for every hamburger and $3 for every fry. And no matter how many x's and y's, we never get bigger than 800. So this first statement has to be true. Okay. The restaurant sells at least 20 hamburgers a day. Okay, so when we talk about numbers, like we're looking here at the values of x plus y. Let's go ahead and change the color here. So it's at least 20 hamburgers. So it says 20 is greater than or equal to x. Well, if x is 20, we could say 20 is greater than or equal to 20, right? Because this was our x. And if we sell 0 fries, well, that's fine, because 20 is greater than or equal to 20. So yeah, we could also say that this is true. The third choice says the restaurant never sells more than 20 hamburgers a day. They never sell. They could sell, right? We just proved that they could sell at least. So no, this is no good. And the fourth one says a good day is when the restaurant makes $800. Well, that sounds nice, but this issue here of good day, no, this is not a math-related question or a math-related statement, but that can't be good. So our answer choices are 1 and 2. Okay. Send me any messages, guys, if you have any questions on this one. Okay. And the last one, ooh, this one's a doozy. So it's a 3-variable system. I know we did discuss this very briefly on one day, but I'm going to go ahead and solve this with you guys. So when I'm setting this up, I want to use elimination. And so I'm going to pick these two equations to set up my A. Okay, so my A would be negative 4x minus 3y minus 5z equals 3. 5x plus 3y minus z equals negative 11. Okay, so I want to add these up, and look, when I see this here, I can see that the negative 3y and the 3y easily simplify out. So we can say negative 4x plus 5x, so that's just 1x. Negative 5z minus z is negative 6z equals 3 minus 11 would be negative 8. So this is my A. I'm going to box this because this is important. To do my B equation, I'm going to take this one and this one for B. And the reason for that is I can see that I have that 3y and that minus 3y, and those are going to be really nice to simplify out. So we'll say 5x plus 3y minus z equals negative 11. X minus 3y plus z equals negative 1. So when I add these up, well, 5x plus 1x is 6x. 3y minus 3y, that simplifies out. Z, negative z plus z, well, that also simplifies out. Okay, that's fine. equals negative 11 minus 1 is negative 12. Okay, and this would be our b. And these are the two equations that we now want to use. So on the video from last week when we did these, we took those two equations, that x minus 6z equals negative 8, and that 6x equals negative 12, and we consider this as a two variable system. But what do you notice about the second equation? The second equation only has what? It just has the one variable, right? So this is actually going to save us some time when I solve this. What I can do is I can already divide both sides by 6, and I get that x equals, well, negative 12 divided by 6 is negative 2. Very cool. That actually saved us time by eliminating that other variable in there. So be smart about which equations you're trying to add up so you can eliminate variables. So knowing that x equals negative 2, I'm going to take this and I'm going to plug it in this other equation, this our a equation, because this will allow us to solve for z. So we can say x minus 6z equals negative 8. Well, we'll say x is negative 2. So negative 2 minus 6z equals negative 8. So negative 2 minus 6z equals negative 8. We'll add 2 to both sides. So we get negative 6z equals negative 8 plus 2 is negative 6. Divide both sides by negative 6. I get z equals negative 6 over negative 6 is 1. Okay? And so I have x, I have z. To get y, I need to take these equations and plug it into one of the three original. It doesn't matter which one you pick, as long as you do the work correctly, because you'll get the same answer with all of them. And I'm going to take these, and I'm actually going to plug them into that third equation. I like that third equation, just the numbers are a little smaller. So we'll say x minus 3y plus z equals negative 1. Well, x is negative 2 minus 3y plus z, which is 1, equals negative 1. So we've got negative 2 minus 3y plus 1 equals negative 1. We can combine these terms. Negative 2 plus 1 is negative 1. So we'll say negative 3y minus 1 equals negative 1. Add 1 to both sides. So that goes away. So we get negative 3y equals negative 1 plus 1 is 0. Divide both sides by negative 3. So we get y equals, well, 0 divided by negative 3 is 0. Okay. And so then our final answer would be, we want to put this in order. We put our x first, our y, and our z. So our x would be negative 2, comma, 0, comma, 1. And this is your answer. Alright guys, I hope this review helps. Please make sure that you finish all your work on the Pear Deck and you put your notes into your OneNote notebook. If you have any questions, please send me a message and we'll talk to you shortly, guys. And be sure to study. You guys got this. Bye everybody.